In the preceding video, we began to introduce the concept of list comprehensions in Python. In this video, we're going to talk about generator expressions, which look almost identical to list comprehensions. The only difference visually is that list comprehensions are defined in square brackets and generator expressions are defined in parentheses, as you'll see momentarily. Now, there are a couple of other differences between list comprehensions and generator expressions. List comprehensions are what we call greedy expressions. They have to evaluate immediately because their job is to immediately produce a list containing values as specified in the comprehension. On the other hand, there's lots of functional style programming techniques that use what's known as lazy evaluation, where values get produced on demand as needed, or where values only get produced once you begin to execute the code that implements the functional style programming technique. Generator expressions are on-demand expressions. They produce one value at a time as that value gets asked for somewhere in your program. And because of that, they can actually significantly improve performance and reduce memory consumption in an application. So, for example, if I were going to use a list comprehension to produce a 1 million element list, I would have to create that 1 million element list immediately, and all of that memory would be occupied to store the actual elements of the list. On the other hand, if I create a generator expression for 1 million elements, I can ask for one element at a time, do something with that, and then move on, and thus tremendously reduce the amount of memory that's required for processing those 1 million elements. In fact, I could have a billion element generator and maybe my program only asks for 10 elements, so I never wind up processing most of the elements that the generator is capable of producing. And in the case of a list comprehension, I would have to produce all 1 billion elements in advance before I could then use that list of elements and do something with it in the program. So generator expressions can be a really handy technique, and they are just one of several different techniques that are capable of producing values on demand in the Python programming language. So let's go ahead and take a look at a basic generator expression. So I'm going to switch back over to my terminal window here, and for the purpose of this demonstration, we'll define a list called numbers with a bunch of integers in a kind of random order here. Some of them, of course, are positive and some are negative. And we're going to create a little for loop here that's going to use a generator expression to pick off the odd values and just display them. Now, I'll talk more about generator expressions after this as well. So this expression right here looks very much like the list comprehensions we were doing in the preceding video, but notice it has parentheses around it rather than square brackets. If I put square brackets here, it would be a list comprehension, and it would have to first evaluate in its entirety to create the entire list. Only then would the for loop be able to walk through all the elements within that list and then do whatever the for loop says to do in the body here. Now, if it's a generator expression, the for loop can basically ask the expression to give me the next item in the sequence during each iteration of the loop and then print out the corresponding value. So here you can see we're getting the square of x for each value of x in the numbers list, where x divided by 2 gives a remainder that's not equal to 0. So basically, if it's equal to 0, it's even. If it's not equal to 0, it's odd. And so this is going to pick off the odd values in that list and only give me the squares of the odd values. So let's go ahead and execute that loop, and we can see 10 was ignored, but 3 was squared. 7 was squared to give us 49. 1 squared still gives us 1. 9 squared gives us 81. 4 was ignored, 2 was ignored, 8 was ignored, 5 squared gave us 25, and 6 was ignored. So we filtered out half of the elements in this particular example and produced the squares of the other half of the elements. And in terms of performance here, because we're only dealing with 10 elements in the first place, there's no major difference in performance. But if we were dealing with millions of elements, then you would have a massive difference in performance between creating a list of that size, the memory that it takes, versus using a generator expression. Now, just to show you that a generator expression is not actually creating a list, I'm going to take this same expression and assign it to a variable. I'll call it square of odds here. And if I now go and evaluate square of odds, you can see that it tells me this thing is actually a generator object based on a generator expression. So this is just a notation that tells you that this thing is in fact an object in memory.